Hello friends, in this session we are going to discuss quantization process. Quantization means approximation or rounding off. Before discussing quantization process, we have to know what is sampling process. In sampling process, continuous analog signal get converted into discrete signal and this discrete signal or sample signal again get converted into digital signal by means of quantization process. So, quantization process is used to convert discrete time signal into digital signals. Now, to explain quantization process, let us take any arbitrary modulating signal MT, that is continuous analog signal in time domain. After sampling at t equals to nts, where ts is sampling period, we get discrete or sampled signal denoted by m del function of t. At every instant of time, we have sample values corresponding to instantaneous amplitude of modulating signal mt. In modulating signal mt, both time and amplitude are in continuous range. But in discrete version, that is m del t, time is in discrete range but amplitude is continuous. That is called discrete time or sampled signal. Now, after sampling process, we move to the quantization process. As we know that in discrete signal, time axis is discretized, but amplitude axis is continuous. And within finite amplitude range of a signal, we can find infinite number of amplitude levels. This is because our human ear or eye sense only finite differences, but it has an infinite capability. So, in quantization process, infinite number of amplitude level get approximated or rounded off to finite discrete amplitude levels, provided that approximation is selected with minimum error within available range of amplitude. This process of approximation results a digital signal, which having finite number of discrete amplitude levels. And the quantization process is the basic condition for pulse code modulation technique, that is non-reversible process. Now we discuss quantization process in brief. As continuous baseband signal mt is sampled at t equals to nts, and we get sampled or discrete signal, that is m function of nts. This sampled signal is discrete in time, but amplitude is continuous. And after quantization process, an infinite number of amplitude levels within a finite range get converted into a finite set of discrete amplitude levels. And signal is called quantized signal, that is denoted by v function of nts. This quantized signal is discrete in both amplitude and time axis. Now we consider instantaneous and memoryless quantization process. Memoryless and instantaneous means the process is not affected by earlier or later samples at transformation time, that is t equals to nts. Or we can say that it is not affected by delay or advance in time. So, in practice, we use a memoryless quantizer denoted by G. Input of this quantizer is m function of nts. And for our convenience, we call it m. And at the output, we have discrete sample, that is v. Input m has continuous amplitude range, and after quantization we get discrete amplitude range. Now let us consider signal amplitude m with index value of k. As within finite amplitude range, we have infinite number of amplitude levels. And for quantization process, we consider a finite amplitude level and we call it capital I suffix k. The interval of I is from mk to mk plus 1, where index k is from 1 to capital L, where L is called quantization level that is based on our interest. This total number of amplitude level is used in quantizer. The input amplitude, that is M1, M2 up to Mk, are called decision level or decision threshold. So, the input of the quantizer is M suffix k, that is called decision level, and the output of quantizer is V suffix k, that lie within finite amplitude level capital I. And the output amplitude, that is V1, V2 up to VL, are called representation or reconstruction levels. These representation levels, that is V1, V2 up to VL, are within interval of Mk to Mk plus 1, and they are equally spaced. And the spacing between two adjacent representation level is called quantum or step size, that is denoted by small s. This memoryless quantizer having output V equal to g function of M, and this is called characteristic of quantizer, and this is described by the staircase function as shown in figure. In this figure, the quantized signal V is an approximation of input signal M. To understand this, let us consider quantization level L equals to 4, and according to this we have 4 step size, that is delta 0, delta 1, delta 2 and delta 3, and each step size is equal, that is denoted by small s. The step size S is equal to the ratio of peak to peak amplitude upon total number of quantization level, that is 4. So, using this formula, the infinite amplitude level within a finite range get converted into finite discrete level equal to step size, and we get approximate signal called quantized signal. The difference between M and V is called quantization error or quantization noise, that is E equals to V minus M. This quantization error is represented by a shaded portion, and in the process of quantization, this quantization error must be as small as possible. In order to minimize quantization error, step size must decrease, and this result an increase in quantization level. So, the possibility of maximum error is equals to plus minus s by 2, that is half of the step size. So, after approximation, each quantization level, that is L, get converted into a unique n-bit digital word, and according to this, number of levels, that is L, is equals to 2 to power n, where n is called number of bits per word. For example, when n equals to 4, the number of quantization level, that is L, is equals to 2 to power 4, and it is equals to 16. So, with the help of quantization process, the sampled signal having continuous amplitude range get converted into finite amplitude levels, and these are called quantization level. And each quantization level is again converted into a unique n-bit digital word, and that is according to the formula L equals to 2 to power n. Here n is called number of bits per word. Next, on the basis of classification of quantization process, quantizer are of two types. First is called uniform quantization and second is non-uniform quantization. In uniform quantization, the representation level, that is V suffix k, are equally spaced. But in case of non-uniform quantization, the representation level are not equally spaced.